Two-way tables. Two-way tables show two characteristics of any set of data. So here we've surveyed 80 people and we've asked them two questions. The answers that are possible for the first question go up the top. And that was, are you right-footed or left-footed? First question. The possible answers for the second question go at the side. Are you right-handed or left-handed? And the number of people who answered, yes, I'm right-handed and I'm right-footed, goes here. And you'll notice there's a gap because we often have to complete the missing values. The totals around the outside. So these are the totals of the columns, total right-footed, total left-footed. These are the totals of the rows. Total of right-handed people was 60. Total of left-handed people we'll have to work out. And this is the total of everyone. We can get that either by adding up the columns or the rows. So they surveyed 80 people. Two-way tables are useful to let us see if there's a connection between the two characteristics. So if you're right-handed, are you more likely to be right-footed? Now, if we have to find a total, that's easy. We add the numbers that are in that row or column. So 12 plus 8 is 20. And just to check that we're right, we make sure that 60 plus 20 is 80. Yes, it is. But if we have to find something that isn't a total, we're going to need to subtract. So the total of these two is 60, or I could have gone this way. The total of these two is 62. That's fine. Let's go this way because 10 and 60 is easier. We don't have to show the working, but I'm going to put it in. The total of the row is 60. Take away the other one that we know is 10. So that's 50. And double check, 50 plus 12, yes, that's 62. So we've completed the missing values. If you're finding a total, you're going to have to add. If you're finding one of the four numbers in the middle, you'll need to subtract from the total. Now we often get asked to find a percentage, like what percentage of the people in this survey are right-handed. So just a review of percentages, when they're asking me for a percentage, that will equal the amount that we're asking about divided by the total in the question times 100. So that's our formula that we use to find out what a percentage is. So this next question, what percentage of the people in this survey, that is the total we're looking for, are right-handed? That's the amount. So our percentage is the amount out of the total times 100. Percentage is the amount, how many people in total are right-handed, because we want all the people who are right-handed, that's 60. Out of all the people in this survey, 80 times 100. We put that into our calculator. 60 over 80 times 100. 75% of the people in the survey are right-handed. And it was a word question, so we'd say, therefore, 75% are right-handed. Or you could put 75% right-handed here. Now the next question is, what percentage of the right-handed people are left-footed? So we're only taking this out of the right-handed people. We're not taking it out of everybody. All the right-handed people, that's 60. That's our total. Out of only those, how many are left-footed? So that's only out of the right-handed people, 10 are left-footed, and that's our amount. So we have to be quite careful when we're reading the question that we see what the total is that they're asking for and who the people are that they are asking for. So my percentage will be my amount out of my total times 100. Use your calculator. Amount out of the total times 100. Oops. Amount out of the total times 100. If you get the funny answer like this, remember to push the double arrow key. 16.66 for Peter. Question will be 1 decimal place. 16.7% are left-footed out of the right-handed people. So that says if you're right-handed, you're more likely to be right-footed as well.